Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking about moles. All right, we're not talking about our fuzzy creatures that dig holes in our backyard or the black marks on our faces or freckles. We're talking about a unit of measurement, okay? And just like when you go to the store to go buy a dozen eggs, okay, right? Do you just go to the store and buy one egg? No, normally you buy them by the dozen, right? We use a dozen as a unit to describe 12 things. Can you go buy a dozen donuts, right? You can go buy a dozen sodas, right? They come in packs of 12, right? Or you can even, in soda, they just say a pack, right? We think of 12 or 24, depending on what it is. And these names and terms, okay, are given to represent a specific number of items, right? So 12 eggs is just a dozen, okay? You can think of a ream of paper. A ream of paper is 500 pages, right? Instead of just saying 500 pages, we just say a ream. It's a ream of paper. In chemistry, when we're working with really small particles, we need to use a representative particle to describe how many things are in a given space. So a mole is equal to 6.02 times 10 to the 23rd particles, okay? And it could be anything. You could have a mole of balloons. You can have a mole of, I don't know, pens, okay? A mole of eggs. But that number, a mole, would mean that there is a lot of them. 6.02 times 10 to the 23rd. It's a massive number, okay? I recommend you watch the video from a TED Ed video before you listen to this further, right? That gives a great explanation of what a mole is and what it represents. But when we're working in chemistry, we have extremely small objects, and working with numbers that are this large can get kind of hard to work with. So what they did is said, well, if we have this many of a thing, we call it a mole, right? We have 1 mole of that substance. Let me walk over here and grab one of my examples here. Grab a couple of these. Got some jars that I can show you. Okay. So if I'm thinking about a mole of something, right, I have silicon here. It's in this jar, and you can see that it's moving around. And inside of here, I have 1 mole of silicon. So of the atoms of silicon, I have 6.02 times 10 to the 23rd atoms of silicon. And how do I know that? Well, we actually call that, we use the thing called a molar mass. And we will teach that later on. But this is what about a mole looks like when we're thinking of silicon, okay? NaCl, table salt, right? This rock salt here, oh, it's taking up a little bit more space, right, than our silicon, right? And that's because we're thinking of a mole of NaCl. Okay, the mole of silicon is just 1 atom. NaCl is a compound, and it's made up of 2 atoms. So if we look in here, it's going to be a little bit bigger, but can we think of a mole of atoms and a mole of compounds or molecules? Yeah, we can think of them as 2 different things. Like silicon's just individual atoms, and we would have 1 mole of 2 atoms combined. Okay, all right, and then we have another example of sugar. Okay, this is a mole of what a mole of sugar would look like. Okay, and it's even bigger. There's a lot more in here, and why is that? Because sucrose is a large molecule. Okay, it's got over 40 atoms in it compared to just 2 in NaCl. All right. And we can think of a mole as just representing 6.02 times 10 to the 23rd items, okay, or things. And that can be molecules. It could be compounds. It could even be just individual atoms, okay? We typically don't use moles with macroscopic large items, like a mole of pens, because that would cover the entire surface of the earth, like miles deep in pens. That is how big that number is. It's a massive number. But atoms are so small that when we have a mole of them, they fit in this jar. Okay, and it's a convenient unit to use. If I had 2 moles, it's about twice as much as this. And I actually know how many atoms are in here because of what we call the molar mass. And I will be getting to that in another video. But the whole idea, okay, right, right, and here's our notes that we filled out in class, all right, is that when we have 6.02 times 10 to the 23rd, it can represent different things like atoms, compounds, and molecules and such, right? We can think of atoms, molecules, and formula units, okay, like even compounds of ionic and covalent compounds, and so forth. I'm trying to do anything else. If you have any more questions about this, you can come talk to me, but the big thing to take away is 1 mole is equal to 6.02 times 10 to the 23rd. It's just like a dozen is equal to 12 eggs. That's all it is, right? But we're using a massive number that you're now starting to become familiar with, and you're going to be using it quite a bit to solve problems, okay? All right, because what's nice about this is I can actually tell you how many atoms are in this amount with our conversion tools that we learned in the previous video, okay? If you have any other questions, watch that other video on TED Ed. It's a great illustration of applying molar concepts and numbers to our daily life. So thanks again for watching. Until next time.